In a hospital in Pennsylvania, a young Amish child arrives with a brain that is swelling inside its own skull. The doctors run every test they have: infection, injury, autoimmune disease. They check for all of it, and nothing explains what they are looking at. The inflammation keeps climbing. The child needs a neurosurgeon, and for a while, nobody in that room can tell the parents why this is happening to their kid. It turns out the answer was written down more than 280 years ago. In 2025, researchers at Children's Hospital of Philadelphia and a small genetics clinic in Lancaster County traced cases like this one to a single genetic fault called complement factor Y deficiency. In the general population, it is almost unheard of, fewer than 1 in a million births. Among the Old Order Amish, the same study found it more than 4,500 times more common, showing up in as many as 1 in 730 babies born into that community. And none of this is random. It is the predictable arithmetic of how this community is built. Today, there are 410,955 Amish living in North America, and almost all of them trace back to about 80 original Amish founders who arrived in the 1700s. The Amish do not take converts, and they only marry other Amish, so that tiny founding group never got diluted. The entire gene pool still runs on the same handful of bloodlines it started with. Geneticists have a name for what that does. They call it the founder effect, and it is the reason this one community carries rare diseases at rates that show up nowhere else on Earth. But here is the part almost nobody tells you. The same thing that gives this community these diseases is the reason it might one day cure them. Here is how a promise the Amish made to stay separate from the world ended up hidden inside their DNA, and why doctors are now racing to read it. To understand how one gene fault gets this common, you have to understand the single rule that shapes almost everything about Amish life. The Amish live separate from the outside world on purpose. It is the center of who they are. They drive horse and buggy instead of cars. They light their homes without the public power grid, and they pull their children out of formal school after the 8th grade. And that same instinct to stay separate governs who they are allowed to marry. You are Amish because you were born Amish. Outsiders almost never join, and the few who try rarely stay for life. So for nearly 300 years, the Amish have married other Amish, generation after generation, inside the same closed community. Marriages happen within the church, and even when a couple comes from 2 different Amish settlements hundreds of miles apart, they are still drawing from the same original stock of families. There is no fresh blood coming in from the towns and cities around them. Genetically, that has a very specific effect. The gene pool never gets refreshed from the outside. Whatever was in the founders is still in the population today, just spread across far more people, and there are far more of them now. As of June 2025, there are 410,955 Amish living in North America. That number is not climbing because outsiders are converting. It is climbing because Amish families are large, and the population roughly doubles every 20 years, adding around 10,000 people in a single year. A tiny founding group has multiplied into nearly 500,000 descendants, and almost none of that growth brought in new genes from anywhere else. So when a rare gene sits in that founding group, it does not stay rare. It rides along with the whole community as it grows, copied into every new generation. To see how powerful that is, you have to go back to the beginning, to the handful of families this entire population came from. When geneticists study the Amish, they can trace the whole population back to a startlingly small number of people. The clinic that helped make the 2025 discovery puts it at about 80 Amish founders, plus a few hundred more on the closely related Mennonite side. Roughly 80 people, most of whom arrived from Europe in the 1700s, are the source of almost every Amish person alive today. The Amish began as a small Anabaptist movement that broke away in Europe in the late 1600s, and only small groups ever made the journey across the ocean to Pennsylvania. That is the entire reason the founding pool was so tiny in the first place. A faith built on separation started out, by its own history, as just a few hundred people. That is what geneticists call the founder effect. Here is the simplest way to picture it. Imagine a giant jar filled with every color of marble. That is the gene pool of a huge mixed population. Now reach in and grab just 80 marbles at random and start a brand new jar using only those. Whatever colors you happen to grab are now the only colors that exist. If one of those 80 marbles carried something rare, that rare thing is not rare in the new jar anymore. It is a much bigger slice of a much smaller pool. Genes work the same way. Most of the dangerous ones we are talking about are recessive. That means a child only gets sick if they inherit 2 broken copies, one from each parent. Inherit just one, and you are a carrier. You are completely healthy, you never have a single symptom, and you can pass that hidden copy down for generations without anyone ever knowing it is there. In a big open population, the odds of 2 carriers ever meeting and having a child together are tiny. You could carry one of these genes your whole life and never know, because you would almost never meet the one stranger in 100,000 who happens to carry the exact same fault. But in a closed community, descended from 80 founders, where everyone is a distant cousin of everyone else, 2 carriers finding each other stops being a long shot. It becomes ordinary. That is the machinery underneath every disease in this video. A rare mutation got into one of the founders, and the closed marriage rule has been quietly concentrating it ever since. For a long time, nobody could prove that was happening. Then one doctor started keeping records, and a pattern came out of the Lancaster County farmland that no one could ignore. In the 1960s, a physician named Victor McCusick came to Lancaster County to study the Amish, and he found something no textbook had prepared him for. McCusick would go on to be called the father of medical genetics. He built the first great catalog of inherited human conditions, a reference doctors still use in an updated form today. But at this point, he was mostly asking a simple question: which conditions run in this community, and why? Among the old order Amish there, children were being born with a specific and striking condition: very short arms and legs, extra fingers on their hands, malformed teeth and nails, and often a serious hole in the heart. The condition is called Ellis-Van Creveld syndrome. For many of the children born with it, that heart defect is the most dangerous part, and some need major surgery in the first weeks of life just to survive. In the general population, Ellis-Van Creveld is almost a curiosity. It shows up in roughly 1 in 60,000 births. Among the Lancaster County Amish, McCusick found it in something closer to 1 in 5,000. That is more than 10 times as common in one small community. And when researchers looked at how many people silently carried a single copy of the gene, the number was far higher than anyone expected. Just over 12% of that Amish community were carriers, walking around perfectly healthy, with no idea they were passing it on. Then McCusick did the thing that turned a medical oddity into proof of the mechanism. He traced the family trees. Every single Amish child with Ellis-Van Creveld led back through the generations to one couple, a man named Samuel King and his wife, who came to Pennsylvania in 1744. That one husband and wife, more than 2.5 centuries ago, were carrying the gene. Because their descendants married inside the community, the mutation King brought with him spread through thousands of their children and grandchildren until an entire syndrome had a single, findable source you could point to by name. This is the founder effect caught in the act. A real condition in real children, traced back to a real couple who stepped off a boat before the United States even existed. And once you know to look for that pattern, you start seeing it everywhere in these communities. Ellis-Van Creveld was not the exception. It was the first clue. Once doctors understood what was happening, the list of conditions concentrated in these communities grew fast. Take maple syrup urine disease. The name comes from the way it makes a baby's urine smell, oddly sweet, like syrup. Underneath that strange symptom is a metabolic fault. The body cannot properly break down certain building blocks of protein, so they build up as toxins in the blood, and without treatment, they can poison the brain and kill a newborn within days. Even the children who are caught early face a lifetime of careful management, a strict low-protein diet, and special formula, where an ordinary childhood cold can tip them into a life-threatening crisis. Worldwide, this disease strikes about 1 in 185,000 people. Among the Old Order Mennonites, the plain community closest to the Amish, it appears in roughly 1 in 380 births, traced again to a single founder mutation that as many as 1 in 10 people carry in some communities. Then there is Crigler-Najjar syndrome, a disorder where the body cannot clear a waste product called bilirubin. It climbs to levels that can flood the brain and cause permanent damage. To survive, many of these children have to sleep for up to 12 hours a day under special blue lights that break the bilirubin down through their skin, essentially tethered to a lamp every night of their childhood, and the only true cure is a liver transplant. There are only about 100 known cases of the severe form in the entire world. Around 20% of them are in the Pennsylvania Amish. Some of these conditions are so localized, they exist almost nowhere else. There is a disorder known by the initials SIDDT, which is uniformly fatal in the first year of life. When researchers first described it, all 21 known cases came from just 9 families in a single old-order Amish settlement in Belleville, Pennsylvania, every one of them tracing to the same mutation, an entire named disease found in essentially one community on the planet. And there are more. Cartilage hair hypoplasia, a form of dwarfism paired with a weakened immune system, runs at 1 to 2 per 1,000 births among the old order Amish, with roughly 1 in 10 carrying it. Condition after condition, it was the same story. Something rare across the whole world was turning up again and again in one small population. For a long time, the families living through this had no explanation at all. A child would be born healthy, then decline, and nobody could tell them why, or whether the next baby would be next. If you are finding this as fascinating as I do, take a second to subscribe. This channel pulls apart how the Amish actually live, the parts most people never get to see. Now, back to the child we started with, and the discovery that finally explained what was happening inside that swelling brain. The child was suffering from complement factor 1 deficiency, and to understand why it swells the brain, you need to know what complement factor 1 normally does. Your immune system has an ancient, fast-acting weapon called the complement system. It floods in to attack invaders before your body has even figured out what they are, and it is deliberately violent. Complement factor 1 is the brake. Its whole job is to switch that attack off once the threat is gone, so your own healthy tissue does not get caught in the crossfire. Take the brake away, and the attack never fully stops. In a handful of these children, the complement system turns on the brain and spinal cord and will not stand down, causing exactly the runaway inflammation the doctors were staring at. Complete complement factor 1 deficiency is one of the rarest conditions in all of medicine. Before this study, only about 50 cases had ever been described in the entire medical literature anywhere in the world. And then a team at Children's Hospital of Philadelphia, working with the Lancaster Clinic, sequenced the DNA of Amish patients and found the same specific variant over and over, a single version of the gene labeled Y459S. When they ran the numbers, they landed on the figure from the start of this video. In this one population, the fault is more than 4,500 times more common than it is anywhere else on the planet, with as many as 1 in 730 Amish babies born with 2 copies. And here is the quiet tragedy in the data. Out of 11 Amish children they identified carrying both copies, 5 had already suffered serious neurological crises, including brain and spinal cord inflammation, that had sent them to the hospital with no clear diagnosis. Doctors had names for the individual attacks, things like acute disseminated encephalomyelitis and transverse myelitis. But for years, each case had looked like its own isolated medical mystery. They were not isolated at all. They were the same disease, hiding in plain sight in the same bloodline, and nobody had connected them until someone thought to read the genome. Some of these families had spent years going from specialist to specialist, collecting scans and second opinions, and still no answers. The long diagnostic odyssey that rare disease families know all too well. A single genetic test ended it. And there was one more thing, the part that turns this from a tragedy into something else. At least one of these children was treated with a drug called eculizumab, which blocks that overactive complement attack, and the child responded to it. A condition that used to be an unsolvable emergency now had a name, a cause, and a possible treatment. That is only true because someone spent decades building the tools to look, and almost all of those tools trace back to one man. In the 1980s, a Harvard-trained pediatrician named D. Holmes Morton was working in Philadelphia when he came across an Amish boy whose condition had been written off as ordinary cerebral palsy. Morton was not convinced. He dug into the boy's blood chemistry and discovered he actually had a treatable metabolic disorder called glutaric aciduria type 1. For years, this exact condition had been misread as cerebral palsy in Amish children, which meant doctors thought the brain damage was a fixed accident of birth, when in fact it was something you could catch and prevent if you knew to look. That discovery changed the direction of his life. In 1989, Morton and his wife, Caroline Morton, gave up conventional careers and founded the Clinic for Special Children, right in the middle of Lancaster County farmland, to care for these families directly. They built it on an unusual promise to provide world-class genetic medicine at prices plain families could actually afford, funded heavily by the surrounding community rather than by insurance the Amish often do not carry. After a front-page newspaper article drew national attention to the work, donations poured in, including a mass spectrometer, a serious and expensive piece of laboratory equipment reportedly funded by David Packard, the co-founder of Hewlett-Packard. Then, in 1990, the clinic building itself went up the Amish way. In a single day, dozens of local men, Amish carpenters working alongside Amish and Mennonite farmers, raised the entire structure by hand, the same way they would raise a neighbor's barn. Picture that for a second. A cutting-edge genetics clinic, filled with DNA sequencers and lab equipment, standing in a cornfield, built in a day by men in suspenders and straw hats. It is hard to think of a better picture of what this whole story is about. Morton became a legend in the field. He won the Albert Schweitzer Prize for Humanitarianism in 1993 and a MacArthur Genius Grant in 2006. And the clinic he started small has grown into something remarkable. It now cares for more than 1,700 patients and has learned to diagnose and manage over 480 different genetic disorders in these communities, up from just a handful when it opened. It grew so much that in 2024, it moved into a larger facility just to keep up. What began as one doctor questioning one diagnosis turned into the world's leading center for exactly the kind of diseases the founder effect creates. So here's the twist that the fear stories about Amish inbreeding always miss. That same closed bloodline, the one that concentrates these diseases, has made the Amish one of the most valuable populations in all of modern medicine, and it has quietly saved a lot of their own children in the process. Think about what a closed, well-documented population gives researchers. When almost everyone descends from the same 80 founders, and the community keeps careful family records going back centuries, a disease that would be scattered and invisible in the general population instead shows up in a tight, traceable cluster. It is far easier to hunt down the exact broken gene when you can watch it run through one connected family tree. Diseases that might have taken decades to untangle in the wider world get solved here in a fraction of the time. When a rare disease keeps appearing in one interrelated community, researchers can zero in on the exact stretch of DNA that every affected child has in common, and the broken gene is almost always hiding right there. The Amish are not the only population like this. Ashkenazi Jews, Finns, Icelanders, and French Canadians all carry their own concentrated sets of inherited conditions for the same founder reasons. But the Amish are unusually valuable to science for another reason. Between the detailed church genealogies these communities keep and their willingness to work with a clinic they have come to trust, researchers can follow a single disease across a family tree with a completeness that is almost impossible to find anywhere else. And the treatments and knowledge that come out of that work do not stay in Lancaster County. The drug that helped that child, eculizumab, was first developed for other rare disorders entirely, and every time researchers learn more about how the complement system misfires, that understanding flows out to patients everywhere who have nothing to do with the Amish. And the payoff for the community itself is real and measurable. Take that first disorder, the glutaric aciduria, that started the whole clinic. When it goes unrecognized, it damages the brains of around 90% of the children who have it. But with newborn screening and early treatment, the kind the clinic pioneered, that number drops to roughly 35%. Same disease, a fraction of the harm, simply because someone is now watching for it from the first day of a baby's life instead of discovering it after the damage is done. That is what the child from the beginning of this video represents. A community that chose to stay separate from the world accidentally wrote a set of rare diseases deep into its own DNA. And that same separation is now the reason doctors could find them, name them, and start to treat them. The Amish never set out to become a genetic gold mine. Their entire goal was the opposite, to stay apart from the modern world. It just turned out that staying apart left a set of answers hidden in their blood, and we are only now learning how to read them. If you want to see how far that instinct to stay separate really goes, the way the Amish handle death is even stranger than the way they handle life.